Hello students, I'm here with another video from the chapter of class 7th NCERT book, that is Motion and Time. So this is the chapter 13th of your NCERT book from class 7th, okay? So before starting today's video, I would like to tell you all that till now what all things we have discussed in this chapter. So far we have discussed about the word motion, that what does this word motion means. Motion means it is an object which is traveling in and which is traveling with respect to time. Whatever distance is being covered, what is the length, what is the place which is being covered in the motion, or whenever it is said to be in motion, the object is said to be in motion when we can say that an object covers the distance with respect to time. And if we can say that an object is moving, we could say how fast it is moving or how slow it is moving. So by seeing the distance covered with respect to the time, we can also calculate that what is the speed of this object which is moving. Now, if the speed of an object is more, it means that the object is moving in a fast motion. Or when the speed is less, it is known as it could be very easy to understand that this object is moving in a slow motion. Okay, we have also seen that there are different types of motions, that is rectilinear motion, circular motion, rotatory motion. Okay, and also we have seen about uniform motion and non-uniform motion. We have seen this uniform and non-uniform motion in detail. Then what else is that? Well, uniform motion means it is a type of motion where equal distance is covered in equal interval of time. And then if we know, if we talk about a non-uniform motion, it means that the the object which is moving is not going to cover the equal distance and equal interval of time. Means it has the unequal distance and equal interval of time. Okay. So if we talk about non-uniform motion, okay, if we talk about non-uniform motion, it means that, okay, so it means that the object has, this is unequal distance in equal time. Okay, this could be one case, or it could be equal distance but unequal time. Okay, this could be the second part, or both of them are unequal distance and unequal time. So this is the unequal distance in unequal time. It could be in non-uniform motion, could be in three ways, that either the motion could be, the object could be traveling unequal distance and equal interval of time, or both of them are unequal, whether it is time or distance. Okay, so we have also seen about the different speeds, and we have also seen about the type of we have also calculated the average speed. Okay, so average speed, the formula for average speed is that it is the total distance upon total interval of time. And then we have also seen about different types of the graphs which could be made, and some more graphs I'll tell you how to make those graphs. Okay, then we have discussed about one type of motion, that is uniform motion, then second non-uniform motion, and third which we have discussed was the oscillatory motion. So what is that oscillatory motion? So in oscillatory motion we have discussed about the oscillations, then we have discussed about the frequency, we have also discussed about the time period, we have also discussed about the we have seen about the different other words which are related. So amplitude also we have studied. Okay, so what we have seen, what we have studied is that we have all seen about the we have seen about the the vibratory motion or the oscillatory motion. It is having some vocabularies which is always connected to it. Okay, so next we have seen about the we have seen about this oscillatory motion, and the other things, that is pendulum shows this oscillation. And what about one oscillation? We have also defined one oscillation. Fine. Next, what we need to discuss is that there are different types, there are different ways by which we could measure the time, and we could measure the distance, and also we could measure the speed. Now, what we need to study? We need to study the measurement of the time, measurement of the speed, and measurement of the distance. So, if we need to measure the speed, we have to use a device which is known as speedometer. It is known as speedometer. Okay. And if we need to measure this distance, we can use odometer. Okay, now what about time? We need to measure the time using different clocks. Okay, so the speedometer, odometer, and the clocks are the three ways by which we could measure the distance, time, and speed. So these are the three things of measurement which we have measured, which we have studied, and also I have discussed about this odometer, which helps in the measurement of the speed, whereas the odometer is going to measure the distance in it. Next, what we have seen is that we have also seen the different types of clocks. Okay, so we have seen the different types of clocks, where first clock was this the sand clock. Okay, we have seen about the sand clock, and then we have seen about the water clock, we have seen about the candle clock, and also lastly we have seen about the we have got to know about the digital clock as well as the analog clock. Okay, so we have seen the sundials and the moon dials. What is the difference? I mean, how it is so that measurement of time or these clocks are present, and how they are using and different varieties of things, and how they are able to tell the time. So if we see about the sundials are the instruments. These are used for measurement of the time using the sun's position or sun rays. Because of the sun rays, whenever it is falling on the sundial, it forms shadow. So using the shadow, that is going to tell you about the way by which you could measure we could measure the time, and it is very accurate. Okay, so in the olden times, sundials and the moon dials the most common ways to measure the time. Okay, so these moon dials are measuring the time during night time, and because of the help of the moon rays, and the sun rays are helpful for the measurement of the time in the daytime. So these instruments, which like the sundials and the moon dials, I told you that they are using the sun and the moon rays to tell the different time, and that also is very accurate. Okay, so we can see this sundial in some places, even in Ramnagar, even in the place like Jantar Mantar. It is placed, it is already there, and you could visit over those places to see the sundials, actually what it looks like. And it utilizes the sun's rays to give rise to the shadow which is being formed, and you could easily tell how the means this measurement of time is being done during those days. Okay, so we have also seen about the different clocks. Then finally we have come to the point that there are various ways by which you could measure the distance in a very easy way. Okay, and we could also measure the time because of the presence of, nowadays we can see that there are the digital clocks, modern day clocks. Okay, or I should say that measurement of time, whenever we have to measure the time, we use clocks, and the clocks are of two types. One is the olden ancient clocks and the modern clocks. So what about ancient clocks? Ancient clock could be this water clock, sand clock, candle clock, okay, sundials, and the moon dials. Okay, the next, in the modern clock we can see the digital clock, the analog clock, and then we have to see the scientific clock. So these are the various clocks which are the modern day clocks, and now it has become very easy to calculate the accurate time actually. So this accurate time means it could be the time could be measured in the seconds, and after seconds, see, we could measure the time in minutes, we could measure the time in hours, minutes, seconds. Now after that seconds, after seconds, it could be measured in the form of milliseconds, microseconds, nanoseconds. Okay, so it could be the milliseconds, okay, microseconds, and the nanoseconds. Okay, so these are the ways by which we could calculate the speeds, we could calculate the distance, where we could calculate the distance in the form of 10, means if difference of 10 is there, and then if we can calculate 10 to the power minus 6, we could calculate 10 to the power minus 9. Fine, this much accurate distance, time could be compared, which could be easily being understood by using these clocks, which are showing you the very accurate timings. Fine, so scientific clock is one of the most advanced clock. Atomic clock is also there. Scientific clock is used for doing scientific calculations, where this measurement of the time is required in that particular way, in the particular this is required in a particular way. Okay, this is very much necessary. Now next we are going to study about the distance time graph again. Okay, so this we will study distance time graph. Okay, so we have already seen about the distance time graph in the previous classes also. That is it, when it is showing you the different in a straight line, when it shows the uniform motion, and if you could see the zigzag movement, the zigzag lines or the curved lines, it could be the curved motions, it could be non-uniform motion. Okay, so we have seen the main two types of graphs, that is the uniform motion and the non-uniform motion. Okay, now if we need to plot, if we plot the speed on it, so you could also plot the speed on this distance time graph. Okay, how? The time is going to be on the x-axis, the distances could be on the y-axis. Okay, now when distance is in measurement, it is in meters, time is in seconds. Okay, we could mark this, and it has 0 line. Now what about the uniform speed? Uniform speed graph. Okay, what about this uniform speed graph? The uniform speed graph says that whenever the equal distance is traveled in equal interval of time. So if time is 1 second, 2 second, 3 second, the distance could be 1 meter, 2 meter, 3 meter. It is going to form at 1 meter, at 1 second, the distance was about 1 meter. Okay, if 2 seconds, the distance was 2 meters, it was covered. Then for 3 seconds, 3 meters were covered. So we can see, when we join the lines, we can see that it is forming a straight line. So whenever we have a straight line, it means that it shows uniform motion, as well as it shows about the uniform speed. Okay, so this is very easy to understand, that whenever the distance is traveled, equal distance is traveled in equal interval of time, we could easily find out, we could easily tell that it is a uniform speed graph. Okay, similarly, if we calculate the non-uniform speed, then what to do? We can easily calculate the non-uniform speed also by seeing this motion time, this time distance graph. Okay, so time on the x-axis in seconds, and distance is in y-axis. Okay, it is in meters. Fine. Whenever and now what happens, if the object is moving on different speeds, then it forms, for example, 5, 2, 1. Okay, so it could be in 1 second, the distance traveled was about 1 meter. Then in 2 seconds, it was 5 meters, and in 3 seconds, it was 2 meters. So if we draw this graph, it becomes like this. Okay, so if we can see that this is going to form a graph which is in the form of the curve. So if we form a curved line, if we get a curved line, it shows it is a non-uniform motion. Okay, it forms non-uniform motion. So this is how we can easily calculate the type of, we can easily see the type of the graph shows that what kind of motion it is. Okay, now there are different ways of representation. So the way by which you are using the lines to show, so this is known as line graph. Line graph, okay. In maths, I think you all have studied about line graph. So this is line graph, another type of graph which could be drawn with the help of the bars like this. Okay, so it is drawn like this. So bars are drawn. So here this is known as bar graph. Okay, this is known as bar graph. So the different types of graphs are there which could be drawn, which could easily be telling you about the distance and the time, and this shows this is a very easy task that you could easily find out what kind of distance is being traveled, what amount of time it is being taken, what amount of speed it has while moving. So if we need to find out these three parameters, we simply go to this distance. We always check out for the distance, time, graph. Okay, and if we have the curved lines, it means it is a non-uniform speed. If we have a straight line, it is a uniform speed. And if we have now one more type, one more way by which you could understand whether an object is moving or not is that we can see an object is moving or not. It's very easy to understand. I'll just draw a simple graph and I'll tell you how this is being denoted. Okay, this is distance, okay, in y-axis, time on x-axis. Okay, now next, for example, if at once data is 1 second, the distance traveled is 2 meters. In 2 seconds, distance traveled is 2 meters. In 3 seconds also, distance traveled is 2 meters. 4 seconds, distance traveled is 2 meters. How will you draw the graph for this? So 1 second, the distance traveled is 2 meters. For at 0, it was 0. Okay, it was again 2 meters. Then at 2 seconds, distance traveled was 2. 3 second, distance traveled was 2 meters. 4 second, distance traveled was 2 meters. Now, if you draw this line, this is parallel to the time axis. Okay, so x-axis is also known as time axis and y-axis is also known as distance axis. So if we calculate this time axis, we can see that it is parallel to time axis. Okay, this is parallel to time axis. So this means that the body is at rest. Now one more term is this, motion and rest. Till now we were studying about the uniform motion, non-uniform motion, and now we are going to study about the rest also. So it is just the opposite of movement, it is just opposite to the motion, where an object is standing at a place. For example, at 1 second also it was at 2 meters, it means it is not moving. At 3 seconds also it was at 2 meters, it means its position is fixed. If its position is fixed, it means that it is at rest, the body is not moving. So if it is not moving, it is said to be at rest. And if it starts moving, it is known as the body is in motion. Now if it is in motion, whether it is in uniform motion or it is a non-uniform motion, we could easily calculate by comparing the distance traveled in particular time. Okay, so I'll just draw one graph. I'll just tell you one more graph which shows you about the body at rest. So just remember that there could be many types of graphs for showing the distance and time. For example, if you need to draw a graph, the time shows 0 and distance also is 0 meters. Okay, it is in meter, it is in seconds. Then time is in meters. Fine, so time 0, distance 0. Then for 1 second, the distance traveled is 1 meter. For 2 seconds, it is 4 meters. For 3 seconds, it is 8 meters. For 4 seconds, it becomes 12 meters. Now you need to draw the graph. How can you draw the graph? We will use the simple same method. We can take the x-axis and y-axis, and x-axis we get time and at y-axis we can write distance, okay, and this becomes 0. Now what we need to do is, we will see this graph, we will plot the graph. At 0 second, distance was 0 meters, and then 1 second it was 1 meter. We'll draw this, okay, and time is 1, 2, 3 seconds, okay. So the time here is different, okay. So we can just calculate, we can just write this distance properly. How we can write? I'll just let you know. See, if it is y-axis, now how can you draw this? And here what you can do is this, what is the range of the distance? It is 0 to 12, okay, 0 to 12. So you'll write down 2, 4, 6, 8, 10, and we could also draw 12, okay. So this is in meters, distance is in meters on y-axis. On x-axis it is time, 1, 2 and 3, 4 seconds, okay. 0, 1, 2, 3 and 4 seconds, and the time is in seconds, okay. Now please plot the graph, try to plot the graph. So here while plotting the graph, it could be 0 second, 0 meter. For 1 second, 1 meter, it means somewhere here, just here at half, okay. At 2 minutes, 2 seconds, it is 4 meters, it is here, fine. Then at 3 seconds, it is about 8 meters, okay. Here 3 seconds, 8 meters. The next is 4 seconds, it is 12 meters, fine. At last it becomes 12 meters. Now if you plot this graph, you can see that this is drawn in a straight line, okay. It could be in a straight line. So this shows that this type of motion, when we get a straight line, it is slanting to the x-axis, and it is slanting with the time and the distance axis. This shows that this type of graph is showing you uniform motion. Now if motion is uniform, it could be uniform speed, okay. So it shows uniform speed or uniform motion, fine. Now if you need to calculate the distance which is unequal, or it could be unequal interval of time, then it could be formed in a curved way. And if it is in a curved manner, it means that it is the non-uniform motion. And if it is non-uniform motion, we will easily see that it is forming a curve. So it becomes non-uniform motion, and it becomes non-uniform speed. Now in non-uniform speed, there could be 3 criteria. I have told you, whether the distance is equal or not, whether the time is equal or not, or both are equal or not, okay. So there could be 3 cases. So we need to find which case is being followed by this type of motion. Clear? So this is about how will you calculate the speed using this. So at the instant of time, we need to calculate the speed using the distance as well as time, okay. Now at a particular time, at 1 second or 2 seconds, what will be the speed of the object? So the speed of the object could be calculated by using the way by which you are calculating the you're just drawing this graph which is in a straight line. So I'll just calculate one speed, and then I'm going to tell you about what kind of graph was it and what kind of speed is being, how will you calculate the speed actually by seeing the graph, okay. So we'll just take this previous graph only, and where we have drawn at 1 second it was 2 seconds, it was 4 meters. So if we see this, if this is being drawn, if we see that 2 and 4, okay, so it has 2 and 4 somewhere here. Use scale to draw. So how will you calculate the speed? The formula for speed is distance upon time taken, okay, distance upon time taken. So if we calculate distance, what is the distance traveled? Distance is 4 meters upon what is the time taken? 2 seconds. Now if we cancel this, what is the speed? 2 meters per second. Now what about the next? In 3 it was about 6, okay. So what about this? 3 distance was 3 meter, and time was how much? So here you could not see. I'll just draw this at the above. So 2 meter per second this distance has come. Okay, now we calculate some more points. We could calculate some more points. That is, speed is equal to distance upon time. And at 3 seconds, time was 3 seconds. How much distance? 6 meters. Again, 2 meter per second. Okay. Now we calculate at 4. It was, for example, it was 12. Then 12 meters and 4 seconds. It becomes 3 meter per second. Now, if you need to calculate the average speed, then what we can do is, average speed means total distance upon total time taken. Now, what about total speed? If it is 2 meters, you will calculate 2 plus 3, okay, and then 6, or we could calculate this as 5. And time was how much? It was 2 seconds, for example, okay, or 1, 2, 1.5, it was like that, or it could be about 10 seconds. It could just see that it is in 10 seconds, it is in meters. Okay, so we can calculate the average by adding 2 plus 3, 5 plus 5, 10 upon 10 second, 10 meter in 10 seconds. So the answer would be 1 meter per second. So this is how we can calculate the average speed, and also we can calculate the distance traveled by an object. Okay, just see that, suppose that what kind of distance it is being traveled, we can easily say by looking at these distance time graph. Fine. Now next thing I just wanted to tell you that there could be 3 types of graphs. There could be 3 shapes of graphs especially. So the first shape is if the distance time graph is having the straight line like this, if it is having the straight line parallel to the time axis, okay, and the curved line which is having like this. So we can get these 3 types of shapes in the distance time graph, please remember. And if we get the first shape, this is said to be as uniform motion, okay, and if uniform motion is there, then uniform speed would also be there. Uniform motion or uniform speed, okay. Similarly, if we get the second graph, so if we get the second graph, body is at rest, it is not moving, okay, it is not moving, it is at rest, it is not moving at all. Next, the speed is 0, and the next is this non-uniform speed. Why? Because this is uneven graph we are getting on non-uniform speed or non-uniform motion. Okay, so the third one says it is a non-uniform motion, and at the same point we can easily see all these shapes, and we could easily tell what kind of graph is telling you about different types of motion. We could study easily whenever we need to study the distance time graph, and we have to see about the shape of the graph, and by looking at the graph also we can easily tell that what kind of distance, what kind of speed that body is having and it is moving with. Okay, now today this is the most important point to understand, that whenever the speed is uniform, the motion is uniform. If the speed is non-uniform, it is a non-uniform motion, and if the body is at rest, it is not moving at all, so it is at 0 speed. Okay, so this was about to calculate how we can calculate the distance, how we can calculate the speed using the graphs. How can you tell that what kind of distance this is having? So in today's class we have studied about the measurement of time using this distance time graph, where we have drawn the distance time graph in 3 ways, where if body is in motion, if it is in a straight line, it shows the graph in the first graph, if it is in rest, it shows the second type of graph, and if it is in motion, non-uniform motion, it shows this third type of graph where a curved line is seen. Now after seeing this curved line, we can easily calculate the distance, we could easily calculate the time, we could easily calculate the speed. If two of them are given, third one could easily be found out. So children, that is all about the video which I wanted to tell you, that about all these things. I think we have covered the complete chapter, and in the next class I'll discuss about the exercises and some more few points which could be left from this chapter. Okay, so children, that is all for today's video. I'll meet you all in the next video with the next topic to be discussed in this chapter. So that is all for this today's video.